Hello guys, in this video we are given a question for cubic function which we want to see how we can solve the following questions. So the question reads, given f of x is equal to x cubed minus 4x squared minus 11x plus 30. Calculate the coordinates of x-intercepts of f. So let's go to the first one. We want to calculate the coordinates of the x-intercept of f. The first thing we need to do here, we use the try and error method. That will help us to find the first factor of this cubic function. So the correct root, when you substitute here, it must give you 0. So I substituted with x is equal to 2, it gave me 0. So f of 2 is equal to 0 is the first root. But as a factor, it will be equal to x minus 2. That will be my first factor. But we know a cubic function is the multiplication of a linear function and a quadratic function. So this will form our linear function. So now we're just looking for the quadratic function, but yet we don't know that quadratic function. So we multiply this linear function with an unknown quadratic function in its general form, which is ax squared plus bx plus c, identical to x cubed minus 4x squared minus 11x plus 30. Then we expand this side. Expanding this one, this will give us ax cubed plus bx squared plus cx minus 2ax squared minus 2bx minus 2c. This will be equal to x cubed minus 4x squared minus 11x plus 30. Now we equate the terms that are in the same degree. Terms with x cubed and x cubed aside, they equate each other. So ax cubed is equal to x cubed. X cubed and x cubed cancels, leaving 1. Therefore a is equal to 1. Now we are looking for b. We can go to the terms in second degree. Minus 2x squared is equal to minus 4x squared. X squared cancels. Then we'll be left with b minus 2a is equal to minus 4. We have calculated the value of a, then we substitute it in this equation, equal to minus 4. Our answer will be equal to minus 4 plus 2, which is equal to minus 2. The value of c, we can go straight to the constant value, which is minus 2c is equal to 30. Or you can use the term in the first degree, cx minus 2bx should be equal to minus 11x. It gives you the same answer. So here I'm taking minus 2c is equal to 30. This will give me the value of c as minus 15. Therefore, now we go back at this step. So this is x minus 2 multiplied by x squared minus 2x minus 15. But in this case, we can factorize this quadratic expression by looking for the factors of minus 15. The factors of minus 15, that gives us minus 2 when we add is minus 5 plus 3. Then we equate everything to 0. Then xc is equal to 2, or xc is equal to 5, or xc is equal to minus 3. So the coordinates is made up of x and y values. So these are our x-intercepts. Calculate the coordinates of the y-intercept. Y-intercept, we said we can take the value of d. This is the value of d, which is 30. So meaning 30 is the y-intercept, 0 and 30. Number 3, calculate the coordinates of the stationary points of f. The first step is to find the first derivative of f. This will give us 3x squared minus 8x minus 11. The derivative of a constant is 0. Then we equate it to 0, meaning by factorizing this part we get x plus 1 and 3x minus 11 as our factors. This will give us x is equal to minus 1 and x is equal to 11 over 3. So these are the x coordinates of the turning point. Now I want to find the y coordinates. We substitute the x values into the original equation so that we can get their y values. So firstly, we are substituting with minus 1. So this is minus 1 cubed minus 4 open bracket minus 1 squared minus 11 open bracket minus 1 and plus 30. Y is equal to 36. Minus 1 and 36. Let's find the other y value when xa is equal to 11 over 3 minus 400 over 27. So the other coordinate of the turning point is 11 over 3 minus 400 over 27.